The story unfolds in the late 1930s, amidst the shadow of Nazi Germany. Lise Meitner, an Austrian-born Jewish physicist, was then considered one of the world's leading physicists. She worked at the Kaiser Wilhelm Institute in Berlin, where she collaborated with Otto Hahn for many years on studies of radioactivity. However, in 1938, with Germany's annexation of Austria-Anschluss, Meitner's situation became perilous. Due to her Jewish heritage, she was no longer safe in Germany and had to flee. Meitner clandestinely escaped to the Netherlands and then to Sweden, where she found refuge at the Mann-Siegbahn Institute in Stockholm. Otto Hahn and his assistant Fritz Strassmann continued their work in Berlin after Meitner's departure. By late 1938, they discovered that uranium atoms unexpectedly transformed into barium under neutron bombardment. However, they struggled to explain how this transformation occurred. Meitner and her nephew Otto Robert Frisch, while evaluating Hahn and Strassmann's results, realized that when uranium nuclei were bombarded with neutrons, they split in two, releasing a significant amount of energy in the process. Meitner and Frisch termed this process nuclear fission and published their findings in the journal Nature in early 1939. This discovery was a practical application of the E-mc2 equation, and theoretically had the potential to produce infinite energy. The discovery of nuclear fission quickly led to the development of nuclear reactors and atomic bombs. At the end of World War II, this technology was used in the atomic bombs dropped on Hiroshima and Nagasaki, ending the war but also marking the beginning of the nuclear arms race. Meitner's role in this discovery was long overlooked. In 1944, the Nobel Prize in Chemistry was awarded to Otto Hahn for defining nuclear fission as a chemical process. However, Meitner's significant contributions to this discovery began to be recognized over time. In 1966, Hahn, Meitner, and Strassmann were awarded the Enrico Fermi Award by the American Nuclear Society for the discovery and development of nuclear fission, while often remembered as a forgotten woman. In scientific history, Meitner's story became a turning point highlighting the importance of gender equality and recognition in science. Her career illustrates the challenges and barriers faced by women in science and how contributions can be acknowledged over time. When Meitner died at the age of 89 in 1968, she was recognized as a pioneer in nuclear physics. However, she never received the Nobel Prize. Nevertheless, she became a respected figure both within and outside the scientific community. After her death, Element 109 was named Meitnerium in her honor, a kind of posthumous recognition from the Nobel Committee that had denied her the Nobel Prize. The discovery by Meitner and Hahn also brought about discussions regarding the ethical aspects of science. Meitner opposed the military use of nuclear fission, advocating for science to serve humanity. During and after World War II, she emphasized the need for scientists to deeply consider the ethical consequences of their work. The discovery of nuclear fission raised profound questions about the relationship between technology and society. While revolutionizing energy production, medicine, and scientific research, it also posed risks such as nuclear proliferation and environmental damage. Meitner and Hahn's work helps us understand the complex effects of science and technology on humanity. The discovery of nuclear fission by Lise Meitner and Otto Hahn is one of the most important moments in scientific history. This story illustrates collaboration in science, overcoming challenges, and the profound impacts of science on society. Meitner's story underscores the importance of gender equality and justice in science. The development of science and technology is also a process that requires ethical and social responsibility. Meitner and Hahn's discovery illuminates both the bright and shadowy aspects of this process.